Hello fellow tilters. I wanted to share with you my most recent prototype that I've put together. I've been working on tilting three-wheelers for a while. You can see the one in the background over here. I threw this one together primarily because I wanted to be able to very easily adjust several different measurements on the vehicle and see how it is going to modify and change the handling of the vehicle. Invariably, when you go down a path of building one of these things, you spend about a year designing it, and then ultimately you start building, and it takes about a year before you get to the point where you can actually try it out. And in the first 30 seconds of riding this one over here, I determined my design for tilting the vehicle is not going to work. And so you're back to the drawing board. And invariably when you are building the vehicle, you know, you're being real careful and nice and making sure it all looks pretty in fabrication and whatnot. And I've been cutting and working on that thing for a good while, changing different designs. It takes forever before you can try it out again. So I said, let me throw this together. It doesn't have to be pretty. I just wanted to test out various different measurements and see how it is going to behave. And I will share with you here as I modify different things. I'll take videos of it and share with you the results that I'm actually getting on this thing. You know, I have people that ask me, why build a tilting vehicle like this? He says, you're building what? There's a variety of reasons over here. When your city traffic is starting to look like that right there, my city thankfully doesn't look like that quite yet, but when you start fighting traffic like that, people start thinking there's got to be a better way. And so we've got these 5,000-pound vehicles cruising down the road. We'll hold 5 passengers, and we got 1 person driving the vehicle in the car. So folks say, well, let's start getting into a real tight package. We'll design this thing maximum 2 people, and we'll get far better gas mileage. You can get a lot more through traffic this way, and thus we start having these miniature pint-sized vehicles. Well, if you get a real narrow vehicle, you've got to tilt it or it's going to fall over, and thus the need for a tilting vehicle. Now you could do 4 wheels tilting, 3. Why go 3? Well, it's less rolling resistance, less weight, and it's a simpler design, and thus 3 wheels can get the job done. Having 3 wheels gives you stability, so that when you get to a stop, you don't have to put your feet down, so you can have an enclosed vehicle, and that can be a huge benefit. There's several motorcycles and scooters that have come out with 2 wheels in the front. That gives you better stability and handling. Having 2 wheels on the ground can really be a huge benefit right there. A number of different designs that you can go with. This one is a 1 front, 1 tilt, so only 1 wheel is tilting. The 2 wheels in the back don't tilt, and but you could do a design with all 3 wheels tilting. Then you need to have trailing arms on either side over here to actually tilt the vehicle, kind of like that. Then you can go with 2 wheels in the front with all 3 of them tilting. I've even seen a configuration of 2 in the front and only the back wheel tilts, which is kind of unusual setup right there. Here is the lean machine over here. This was on display in Epcot, and this is the vehicle that ultimately got me interested in tilting 3-wheelers. Pretty cool little vehicle. Used foot pedals to tilt the vehicle, and then you had regular handlebars to steer it. They never took it to market, and it was just an experiment for them. Here's the Honda Gyro right here, and there's thousands on the road of these things. So this particular design is proven in several different models. Here's the Carver right here. Phenomenally handling vehicle right there. Super fun to drive. And quite frankly, the main reason that I'm designing a 3-wheeler is to have a unique really fun vehicle to drive. We've got room on the road, so I'm not necessarily trying to save gas, which is a nice thing to have, but ultimately I want to have a really fun vehicle to drive down the road. And you watch the videos of where they are looking into this vehicle, test driving it, Jay Leno and others, and they just can't stop smiling. This thing is so much fun to drive. And so that's the reason that I'm designing a tilting three-wheeler. A couple other interesting designs. This is the Clever that I mentioned earlier over here, and BMW worked on this vehicle, spent over $1 million on it, and never did get it completed where it was working right. Got another picture of it right here. That's it right there. And the reason it wasn't working is that they were steering the vehicle with a regular steering wheel, and then they were monitoring the speed of the front wheel and how far you're turning the vehicle with a microcontroller, and then determining with hydraulics how much they need to tilt the vehicle. Well, they weren't counter steering, and invariably when you ride a bike or a motorcycle, if you want to turn right, you actually move the wheel just slightly to the left to get the vehicle falling over, the bike falling over, and then you turn into your turn. That's called counter steering. Very, very important. If you try to turn the wheel before you start tilting, the vehicle starts falling to the opposite direction. And so then the hydraulics have to really kick in gear and huge amount of force to get the vehicle to tilt. This is what they were fighting over here with the Clever. And if you do a real sharp turn, the forces are so severe that the vehicle was trying to flip like I showed you in that picture right there. Never did figure that out, how to fix that. Here is the Venture 1, and this was going to be the American version of the Carver. It was using the Van Brink technology for the thing, but the company they ultimately hired said it was going to take millions of dollars to rework the vehicle, and it got canned, unfortunately. I was looking forward to seeing that vehicle right here. So how do you deal with this counter steer problem? I'll show you here in a minute. This is a free-to-caster setup. But another one I wanted to show you over here is this one by Center Tracks. It's called a CTX, and Marcus Schulten is working on this one right now. He's from South Africa. He's in California right now. Has all kinds of fabrication experience and working with cars and manufacturing, and he wants to get that vehicle on the road. Look at center-tracks, trax.com, and look at his website right now. He's got a prototype that he's put together to proof of concept, and figuring some other things out on that. There's two kinds of tilters. We've got the natural tilter where you balance like a motorcycle, and then you've got the force tilter like this one where you are in control of the tilt. Very different tilters. The force tilter is a lot harder to build, more complex because you got to figure out how to power that tilt. But the benefits of a force tilter is that you are in control of the tilt. And if you are in a full tilt and hit ice or gravel or dirt, and you go into a slide, you can hold the vehicle in that position without letting it hit the ground. Then when you hit tarmac again, you can bring it back up, and away you go. It's very, very hard to roll a force tilt vehicle like this if you are steering the tilt. On the other hand, a natural tilter over there will hit the ground. When it loses traction over there, it's coming down. The negative of a force tilter is when you go over uneven terrain, like if you go through an intersection where the road is curved over here and you come over at an angle like that, it does this number right here on you, and you will feel that just like a car. because you're tied to the wheels. If you're in a natural tilter, you don't feel that. Wheels do that, but you just go straight because you're balanced. And that's a neat benefit of a natural tilter. Marcus on the CTX over here has come up with a strategy where he is monitoring the traction of the wheels. And if he detects that it's lost traction, he's got air pneumatics that will bring the vehicle up level. And also when you slow down to a stop, it'll hold the vehicle in an upright position. And he said it's working great. I'll be interested to see how that actually operates, but he's done a lot of work. His has all three wheels tilting. When you have the rear wheels tilting over here, you got to have chains coming over here to differential and then the motor, so you end up with 3 chains on that setup. I looked at that strategy over there, but decided it was more complicated than I wanted to go with, and I've gone with this one because this is the simplest tilting design out of all of them over here. Having one wheel in the front simplifies the suspension and steering, and then having the engine here on a platform that is not tilting to be able to tie in the wheels simplifies that tremendously as well. When you get into 2 front wheels that are tilting, the issue is the suspension. You can do a parallelogram that tilts over here, works great, but then when you try to figure out your suspension, that's where it gets difficult. A number of folks have tried to design it using A-arms, double A-arms over there, but invariably what people are finding out is that you need the suspension in the direction of the wheel, in the plane of the wheel. So if it's in a tilt position over here, you want the suspension, the wheel to be bouncing in that direction here. But if you do A-arms over here, say here's the wheel and here's your A-arms, and you tilt it, here's your tilted wheel, now when you hit a bump it's doing this. And so the wheel is moving up and down this way instead of here. And what that causes is tire scrub around corners. And if you're flying around a corner at 70 miles an hour banked, and you hit some bumps over here, it can be very, very unnerving. Now, what folks have found out is that it's worse if you have a force tilter in that setup than if you have a natural tilter. Others have tried to do uneven length A-arms, which helps to straighten out that bounce just a little bit, and that seems to be helping as well. Another neat vehicle over here is the Wessel, and this is an ATV 4-wheeler with amazing travel, suspension travel on this thing, and I still have yet to understand how they're able to get their universal joints to work in the back for the engine hook up to the wheels. I mean, we're talking 55 degrees on these universal joints, but they've got a phenomenal video over here where they've got alternating bumps, and he rides the thing over. This is a natural tilter, and the wheels are just bouncing up and down, and the rider is just nice and smooth, running right over it. If you were in a force tilter in that situation, that thing would be doing this, and just like a car. So that's the drawback of a force tilter. Another interesting design is the Toyota iRoad, and this one has rear wheel steering on it, so the front wheels do not steer at all. And that's an interesting concept, because if you steer the rear wheel, say you want to go right, you're actually steering it to the left. And so naturally the vehicle is going to fall in the direction that you're wanting to go, instead of opposite like if you're steering the front. And so they don't have to worry about counter steer. And so they've got a little motor that is tilting the vehicle, same like the Clever over here, picking up speed and how much you're steering the vehicle and determining how much to tilt the vehicle over, and it's working. Now that vehicle can only go up to about 40 miles an hour. It's electric, and I'm interested to see how it's going to behave at higher speeds. I think it'll do okay, but that's interesting when you're dealing with a rear-wheel steer model. One other unique vehicle is this one right here, which is the Sway. And what's interesting about this is it has a platform where you mount your feet over here, where you can actually then control your tilt. So this is both a forced tilter and a natural tilter all in one. And you have tremendous control on this little vehicle. I've seen videos of them doing donuts on the ice and it's not falling over because you have control of that tilt. But it doesn't lend itself in that strategy right there if you want an enclosed tilter over here. So that strategy or design is not what I'm looking for. I want to have an enclosed tilter similar to the Carver or the Venture 1 vehicle over here as you go down the road. You know, there's just nothing like it on the road except a motorcycle. But people are getting killed every single day on motorcycles. And it's just not worth it if there's that much risk involved in having fun on your ride. But in an enclosed vehicle over here, you can put a full roll cage around you and you have a much greater chance of surviving a wreck in a vehicle like this. So that's backgrounds on various vehicles, forced versus natural tilting, some of the pros and cons that you'll end up seeing in these vehicles, benefits of being able to have a very small vehicle, streamlined, be able to get 100 miles an hour per gallon or higher, and that's all the huge benefits of having a real small vehicle like this. Well, let me show you in more detail this prototype over here. I'll walk around the vehicle. All right, I will walk around the vehicle over here. First of all, the angle over here on the steering axis of the wheel, I want to be able to adjust it easily, quickly, and so you can see how I've got bolts over here. I can move it. But this is the steepest that I'm wanting to test, and this is at 25 degrees. Bicycles are at about 14 degrees, and I also want to test it straight up and down. I end up flipping the fork all the way around to get me a little bit of trail, but I don't think there's enough trail there. It's just barely an inch right here when you look at this. So I may modify that fork over there when I'm testing it straight up and down. And I have done some testing and it actually behaves very well. Gives you nice, light, quick, responsive steering. Here you can see the tie rod that I have. Mounts in the front right here and then goes all the way to the tilting mechanism right here. And I'm using a motorcycle dampener right here, and it's got an adjustment right here where you can adjust it up or down, light or stiff. In this configuration with it tilted, or at least with a very high steering angle right here, if I have it very light on the dampener, it feels like the wheel is delayed. So you tilt the vehicle and it waits, and then it flops over. You go the other way, it waits, and then it flops back over again and doesn't feel right. And I think that's because of the geometry of the wheel over there, where it's trying to lift the vehicle up or down to go past the center point. When you tighten the dampener over here, it pushes the wheel enough to get it to move over. What's neat about this dampener, and Tom Blackburn is the one that figured out that you need to have this, is that when you are in control, when you are steering the vehicle over here, let me loosen this. So when you push it, and you can see how the wheel is turning back and forth, that as you try to make a right-hand turn, you push the wheel to the right, but it is through the dampener, and so it allows the front wheel to counter-steer just enough to work. The front wheel wants to go straight, and as you turn, it'll kind of be left behind just an instant to get you off balance and then to move to into the turn, and it works great. But you do want to adjust the dampening force over here to figure that out. These dampeners are about $45 on eBay. The only problem with using one of these is that it's very lightweight. So, you know, for a small vehicle like this, it'll work fine. But when you go in reverse, you need to have it locked completely over here, so you're tied to the front wheel so you can steer it. And so this won't work very well in reverse. What I've used over here, Tom has talked about, is using a dual arm steering cylinder, and then you tie the fluid from one side to the other together, and you put it through a dampener, a controlled dampener over here that you can control the dampening on the thing, and that's a lot more solid and works really well. To show you now the tilting mechanism over here, and let me set this thing up on the tripod again so that I can show you doing the tilt. Alright, let me show the tilting setup over here. It has both hand and foot pedals on this one. I figured I was just going to do the hand, and I thought, hey, I've got the feet free. Let's go ahead and put the feet pedals on here as well. I've got the feet pedals a little closer than they need to be, but just for test purposes over here works fine. I've used regular idler pulleys in the front and in the back over here. They have bearings inside of them, about $5 a pop for their lawnmower idler pulleys. And then I have made my own pulleys on the side, made them kind of like a triangle shape over here, primarily for ground clearance. And it's oak on the inside over here, and then I've wrapped this with rubber over here to give it better grip, and then I've stapled the cable in the groove over here so it doesn't slip. And then I've just got regular tie rods from here to the back. Now, I've already made a modification, pretty big modification on this one. Originally I had the tilting set up with bell cranks in the back over here and tie rods. So I had tie rods here, and I had a shaft over here that I could move the bell crank up or down on depending on how I had the setting. But my goal here is to adjust the angle that this thing is tilting at, and I've got it as high as you can set it right here. This is 14 degrees on the lean machine, and on the Carver, their patents say that the angle is at 7 degrees. So this is quite a hefty angle. So here's my bearing pivot points right here. I've got them on car bushings, and so that's my axis. You know, you look at that, you would think, man, are we even above the center of gravity? But we are. But it makes it for a light tilt. When you start to lower this down over here, your axis is over here, so you got more weight above that pivot point, and makes for a heavier tilt force. So I've got various adjustments over here that I can change this angle. What's interesting is you get this rear wheel steering over here. Let me show you this over here real quick. Alright, watch the rear wheels over here as I steer this thing. And it's steering into the turn over here. And that's a lot of rear wheel steer right there. And so the steeper that angle, the more you get of rear wheel steer. Now, if it's flat, you still will get a little bit of steer because it's tilting at the base of the wheel over here. So if I angle this thing straight down to this point right over here, I won't get any rear wheel steer on this thing. But if you angle it even more, you'll get steering in the opposite direction, which is kind of interesting. There are vehicles out there that use this rear wheel steer where at low speeds they want it to steer in the opposite direction, but at high speeds they want it to steer in the direction that you're actually turning. Alright, in the rear over here you can see the wooden pulley that I made in the back, and it's a good sized pulley, and then put laminated with metal on the edges over here, again put rubber, and welded a nut on the end right here, and then have a bolt that I've drilled a hole all the way through, and essentially I've just got some crimps bushings on the end of it right here. This is being powered by a little electric motor, and this came off of a motorcycle razor. This is my son's razor that was sitting in the garage forever and wasn't getting used, so I thought I'd give it some use. And there are 3 12-volt batteries tucked down in here. I had to buy new batteries, of course, because it's been sitting there forever. But very simple design, gets up to about 40 miles an hour, which is as fast as you really want to go on this thing. But it's been a fun thing to build. It took me about 3 months, and it was just liberating not having to worry about being pretty and perfect and everything. And so you can just get in there, think about your design, and build it. And then I can quickly and easily make adjustments. I was hoping to have it where I just have bolts that I can move and quickly try the thing again. One area that I could not do that is these pulleys in the back, because as this thing drops and you adjust the pulleys down, it tilts as well, and so that was just more complicated than I wanted to mess with. So I got to break this weld right here and re-weld it every time that I change the angle in the back. Next video I will show some riding on this thing and tell you how it's behaving. It's been a lot of fun working with this. Good luck with your builds as well.